Hello friends, welcome to Systematic Physics. Here we will be guiding you for content of physics for boards, NEET and JEE. Oscillations, part 9 of 9. Solve problems. Problem number 11. A particle of mass 200 gram performs SHM of amplitude 0.1 meter and time period 3.14 seconds. Find the kinetic energy and potential energy when it is at a distance of 0.03 meter from the mean position. M is equal to 200 gram, so M is equal to 0.2 kg. A is equal to 0.1 meter, T is equal to 3.14 seconds. So I can get omega from there, which is equal to 2 radians per second. X is equal to 0.03 meter. Potential energy, PE, is equal to half m omega square x square. Once you put the values of m, omega and x, you get PE is equal to 3.6 into 10 raised to minus 4 joule. Now kinetic energy is equal to half m omega square a square minus x square. Put the values of m, omega, a and x, you get Ke is equal to 3.64 into 10 raised to minus 3 joule. Problem number 12. The total energy of particle of mass 200 gram performing SHM is 10 raised to minus 3 joule. Find its maximum velocity and period if the amplitude is 5 centimeter. M is equal to 0.2 kg. Total energy is equal to 10 raised to minus 3 joule. TE is equal to half m omega square a square. Now once you put the values, all the values, you get a omega square is equal to 10 to 10 raised to minus 3. So a omega square is 10 raised to minus 2. So a omega is equal to 10 raised to minus 1. So we get V max is equal to a omega, which is 0.1. Now amplitude is known to you, that is 0.05 centimeter. So I put that value, 0.05 into omega is equal to 0.1. So omega is equal to 0.1 upon 0.05, that is 2 radians per second. T is equal to 2 pi by omega. So T is equal to 2 pi by 2, that is pi seconds. So T is equal to 3.14 seconds. 13. A particle of mass 10 gram executes linear SHM of amplitude 5 centimeter with a period of 2 seconds. Find its PE, that is potential energy, and kinetic energy 1/6 seconds after it has passed through the mean position. Solution: M is equal to 10 into 10 raised to minus 3 kg. Amplitude A is equal to 5 into 10 raised to minus 2 meter. Time period capital T is equal to 2 seconds. Omega is equal to 2 pi by capital T. Omega 2 pi by 2. So that is omega is 5 radians per second. T is equal to 1/6 of a second. Displacement X is equal to A sin omega t. You put all the values, you get X is equal to 2.5 into 10 raised to minus 2 meters. Potential energy is equal to 1/2 m omega square x square. Put all the values of m, omega and x, you get potential energy is equal to 3.082 into 10 raised to minus 5 joules. Now kinetic energy is equal to half m omega square a square minus x square. Put all the values of m, omega, a and x, you get kinetic energy is equal to 9.25 into 10 raised to minus 5 joules. Problem number 14. When displacement in SHM is 1/3 of the amplitude, what fraction of the total energy is kinetic and what fraction is potential energy? Now here to understand one thing, that x is equal to a by 3. I know formula for P, that is equal to 1/3 m omega square x square. Put x is equal to a by 3. So that becomes 1/2 m omega square a square upon 9. So now when you take 1/9 out, what is left is 1/2 m omega square a square. That is the formula for total energy. So PE is equal to 1/9 times of total energy. Now kinetic energy Ke is equal to half m omega square a square minus x square. Put x is equal to what? A by 3. So we get half m omega square bracket a square minus a square by 9. So now when again you take 8/9 separate. So what happens? You left with half m omega square a square, which is the total energy. So kinetic energy is 8/9 time of total energy. Problem number 15. A simple pendulum of length 1 meter has a mass of 10 gram and oscillates freely with an amplitude of what? 2 centimeter. Find the potential energy at the extreme point. L is equal to 1 meter. Mass is equal to 10 gram, that is 10 into 10 raised to minus 3 kg. Amplitude A is equal to 2 into 10 raised to minus 2 meter. We know T is equal to 2 pi square root of L by G. Omega is equal to 2 pi by T. Now omega also known to us, that is square root of G by L. So now potential energy is equal to 1 by 2 m omega square A square. Omega square, omega is known to us, square root of G by L. Square of that, so it becomes G by L. So when I substitute all the values, I get potential energy is equal to 19.6 into 10 raised to minus 6 joules. Problem number 16. The period of pendulum gets doubled when its length is increased by 1.2 meter. Calculate its original length and period. L2 is equal to L1 plus 1.2 and T2 is equal to twice of T1. We know the formula. T1 is equal to 2 pi square root of L1 by G. T2 is equal to 2 pi square root of L2 by G. So T2 by T1 would be equal to square root of L2 by L1. L2 is equal to L1 plus 1.2 and T2 is equal to twice of T1. So T1 gets cancelled. You solve that equation, you get L1 is equal to 0.4 meter. Now T1 is equal to 2 pi square root of L1 by G. If I substitute the value of L1, I get T1 is equal to 1.268 seconds. Problem number 17. When the length of the simple pendulum is increased by 22 centimeter, the period changes by 20%. Find the original length of the simple pendulum. T2 is equal to 1.2 times of T1. L2 is equal to L1 plus 22 centimeter. So now what I get here is T1 is equal to 2 pi square root of L1 by G. T2 is equal to 2 pi square root of L2 by G. So I get T2 by T1 is equal to L2 by L1. L2 would be equal to L1 plus 22. I solve this equation and I get L1 is equal to 50 centimeter. Problem number 18. A clock regulated by seconds pendulum keeps correct time. During summer, the length of the pendulum increased to 1.01 meter. How much will the clock gain or lose in one day? T1 is equal to 2 seconds. L2 is equal to 1.01 meter. Period of pendulum in summer, T2 is equal to 2 pi square root of L2 by G. L2 would be 1.01 and you write G as 9.8. So when you solve this, you get T2 is equal to 2.016 seconds. Clock loses 0.01 second in every 2.016 seconds. So in one day, how much it will lose? You have to calculate the number of seconds in a day and oscillations with respect to that. So 24 into 62 into 60, that will give me total seconds, that is 86,400. Now divide that by 2.016, those will give me the number of oscillations made. Now into 0.016 will give me the total time lost in that particular time. So it becomes 687.3 seconds, that is 11 minutes and 27 seconds. Problem number 19. The mass and diameter of the planet are twice those of the Earth. What will be the period of oscillations of pendulum on this planet if it is seconds pendulum on the Earth? M2 is equal to twice M1, T1 is equal to 2 seconds, R2 is equal to twice of R1, T2 is equal to what? That's the question. G1 is equal to Gm1 upon R1 square. G2 is equal to Gm2 upon R2 square. So what I get is G2 by G1 is equal to M2 by M1 into R1 by R2 the whole square. Put all the respective values in the expression. So what I get from there, T1 by T2 is equal to square root of G2 by G1. Now if you see G2 by G1 we have calculated above, that is 1 by 2. And T1 is known to us 2 seconds. So T2 is equal to 2 root 2 seconds, that is root 2 is 1.414. So 2.828 seconds is the final answer. Problem number 20. A bar magnet is vibrating in a uniform magnetic induction of magnitude of which can be changed. Its frequency is found to be reduced to half of the original frequency. When magnetic induction changes to 1.25 into 10 raised to minus 5 Weber per meter square, calculate the original magnetic induction. Now we know N2 is equal to N1 by 2. I know N1 is equal to 1 upon 2 pi square root of M B1 upon I. Why B1? Because M and I, nothing is changing. Only the magnetic induction is changing. So I get N1 by N2 is equal to square root of B1 by B2. I substitute all the values and I get B1 is equal to 5 into 10 raised to minus 5 Weber per meter square. Problem number 21. This is a very important problem. Was asked in one of the exams, competitive exams long back. A bar magnet freely suspended in a magnetic induction H makes 20 oscillations per minute. When another magnet X is brought near it, the number of oscillations are found to be 10 per minute. What is influencing induction of magnet X in terms of H? Now N1 is equal to 20 by 60, N2 is equal to 10 by 60. I hope you are understanding it. Now N1 is equal to 1 upon 2 pi square root of mH upon I. Here B is equal to H. And N2 is equal to 1 upon 2 pi square root of mH minus X upon I. Now if I take a ratio of N1 is to N2, that becomes square root of H minus X upon H. And when you solve it, you get X is equal to 3 by 4 times of H. A bar magnet of moment 2 ampere meter square having moment of inertia 10 raised to minus 6 kg meter square about a transverse axis passing through its center is performing SHM in magnetic induction 0.8 into 10 raised to minus 5 Weber per meter square. Calculate period of bar magnet. M is equal to 2 ampere meter square. I is equal to 10 raised to minus 6 kg meter square. B is equal to 0.8 into 10 raised to minus 5 Weber per meter square. Now T is equal to 2 pi square root of I by MB. Now if I substitute all the values, I get T is equal to 1.57 seconds. Problem number 23. A particle is simultaneously subjected to two SHMs given by x1 is equal to 4 sine bracket 4 pi t plus pi by 6 and x2 is equal to 3 sine bracket 4 pi t plus pi by 3. Determine the amplitude, frequency and initial phase of the resultant motion if x1 and x2 are in centimeters. Comparing the given equations with the standard ones, I get A1 is equal to 4 centimeter. I get A2 is equal to 3 centimeter. Omega is equal to 4 pi radians per second. Alpha 1 is pi by 6 radians and alpha 2 is pi by 3 radians. Now resultant amplitude R is equal to square root of A1 square plus A2 square plus 2A1A2 cos of alpha 1 minus alpha 2. So if I substitute all the values, I get R is equal to 6.766 centimeter. Here you have to remember cos of minus theta is cos theta itself because cos is an even function. Now n is equal to omega by 2 pi. Omega is known to us 4 pi by 2 pi, that becomes 2 hertz. Now tan delta is equal to A1 sin alpha 1 plus A2 sin alpha 2 upon A1 cos alpha 1 plus A2 cos alpha 2. So when I substitute the values of alpha 1, alpha 2, I get A1, A2, I get tan delta is equal to what? 0.9782. So delta is equal to 44 degrees and 22 minutes. From natural tangent table of your logarithmic tables, you will get these values.
We have tried giving you the subject knowledge in very systematic manner. Please like and share the video with your friends and subscribe to stay connected with systematic physics.
Thank you.